All right, so now we are ready to use your electrochemistry toolbox. So if you want to pull out those relationships that we would have looked at last, and you're going to need a calculator and probably a periodic table too, so that if we're looking at our terms of how much and we're wanting in grams, we can look up molar masses. We're going to do two problems. So let's look at my first here. I want to know how much copper, and we're going to do our how much in grams. It is plated out when 10 amps. So here's what we should remember from our toolbox is that amps is the unit for current. It is a derived unit that tells me coulombs per second. So what this 10 amps really means is that there are 10 coulombs for every 1 second. And this current is applied for 30 minutes to our zinc copper electrolytic cell at standard conditions. So if our 10 amps is my derived unit that we're going to use as a conversion factor, it means my given is this 30 minutes. So we're going to put our 30 minutes to start with. Now, we have to be able to use this amps. So amps is looking at coulombs per second. So this means we need our minutes to actually be in units of seconds. So we're going to convert from minutes to seconds. And once I have seconds, I can use that to go to my coulombs using the current. All right, now in quantitative electrochemistry, you're always going to be using that bridge, that Faraday's constant. So if I have coulombs, this gives me the opportunity to use that bridge because in Faraday's constant, it looks at the coulombs per mole of electron. And we can use that mole of electron to go from the copper ion to the actual copper atom, because that's what's going to plate out. And if I have moles of copper, we know we can get to grams of copper. All right, so there's my dimensional analysis. And then we can go back and plug in numbers. So we should know that there are 60 seconds in a minute. This is my amps. So there are 10 coulombs for every second. This is my bridge, my Faraday's constant. And so I have 96,485 coulombs in a mole. And then if I look at this copper half cell, I can see that it has a +2 charge. So this means that 1 mole of copper would have had to lose 2 moles of electrons to form the ion. And then this last step would be one that we're familiar with from first year chem. This would just be the molar mass. So 1 mole of copper has a mass of 63.55 grams from the periodic table. All right, so then we're going to solve. So I'm going to multiply everything on the top together. And then divide that by everything on the bottom multiplied together. All right, so let's talk significant figures. So our given, this 30 minutes, is a counting number. So we're not going to use this for sig figs. The 60 minutes in an hour or 60 seconds in a minute is just a counting number. My amps, though, this is a measured value, so this has 3 sig figs. Faraday's constant has significant figures. It has a whole lot, so we know we don't need to use that. Mole relationships, we know our exact numbers. We don't use those for determining sig figs. And then the molar mass. So it looks like in this problem, my amps has the fewest. It has 3. So I have an answer here of 5.93 grams of copper as my answer. Okay, so there's my problem number 1. Let's look at my problem number 2. So in this case, I want to know how long. So we're looking for time, and I wouldn't specify units. So you can give it in seconds, you can give it in minutes, you can give it in hours. Must a current of 5 amps. Okay, so again, this is my current. It's a derived unit, so what this really means is that there are 5 coulombs for every second. It's being applied to a solution of silver plus 1, and I'm producing 10.5 grams of solid silver. So in this problem, again, if amps is my derived unit that I'm going to use as my conversion factor, then we're going to start off with this 10.5 grams of silver. All right, so again, we have to be able to use Faraday's constant. And in this problem, we either have to get to moles of electrons or coulombs. In this case, because we're starting out with the mass of our metal, we're going to work to get to moles of electrons. So in this case, we're going to start with grams of our metal to moles of our metal, and then moles of the metal to moles of electrons. And then we can use that moles of electrons to get to coulombs. And so now that we have coulombs, we can use our amps to get from coulombs to seconds. Okay, so I'm just going to choose to solve right here and find seconds. So my first step is going to be my molar mass. And so according to the periodic table, there's 107.9 grams in a mole. My 1 mole of silver has a +1 charge, so that means it had to lose 1 electron. And then this would be my Faraday's constant. So there are 96,485 coulombs in a mole. And then this would be my amps. And according to this, there are 5 coulombs per second. So we are ready to solve. So I'm going to multiply everything on the top together and divide that by everything on the bottom multiplied together. And it looks like in this problem, my amps only had 2 sig figs, so my answer is only going to have 2. So I can write it in normal notation. I'm going to put this in scientific notation. I'm going to say my answer is 1.9 times 10 to the third seconds. All right, so those are 2 examples of how to use your quantitative electrochemistry toolbox.